Welcome to our presentation of the Carrier's new low-capacity gas furnaces that have been released this year. The baby boomers, a group of which I'm a proud member, they've started selling their homes and moving into apartments, condos, townhomes. So there's been a construction boom for those units. It's the fastest growing market in the HVAC business. But we discovered that the 40,000 BTU furnaces that used to be the smallest ones in our product line are actually much too large for these applications. In some instances, they're more than twice the capacity that is needed to effectively heat the homes at design temperatures outdoors. So we get nuisance pressure tripping and short run times due to the oversizing issue. So Carrier has developed and now is producing a low capacity gas furnace, they call it. The furnace has a 26,000 BTU input and it comes in two models. The less expensive version is a 1/4 horse PSC motor on the blower. And the more expensive version, which also is electrically a little more efficient, is a 3rd horsepower with the multi-tap ECM blower motor. That's the one I'm sure you'll recall that has the 24-volt input to determine the RPM of the blower motor. And these are intended to serve for new construction in apartments and multifamily dwellings and also the growing popularity of low-energy homes. So these are the specifications on the furnaces. You'll notice the one on the left has the 1/4 horse PSC blower motor, and the one on the right has the multi-tap ECM. They both have 2 burners, 2 heat exchanger cells, and 13,000 BTUs per burner. The cabinet width is the exact same width as our current 40,000 BTU furnace, and the height is exactly the same also. So the footprint is the same. The Propane version is identical to the Carrier PSC version. It's just branded differently and as you know, marketed differently. Now the major differences from the current 40,000 BTU unit is they didn't just downgrade the burners. The Inducer has a different design. They've added an intake choke on it. We'll see that in the upcoming slides. The pressure switches have slightly different set points, and we're lowering the manifold gas pressures in both natural and LP with, dedicated conversion kits. Notice the inlet choke. The Inducer you're used to looking at has 1 large round hole. Now we've downsized it so there's only 3 holes to regulate the volume of flue gas that the Inducer will handle. Those are 3/8 inch OD holes in the choke. If you need to buy a replacement Inducer, it comes as a single stage unit and it includes the choke. You don't have to alter it in any way. Now the outlet choke issue, you may remember the 40,000 furnace. If you have a flue vent that is 10 equivalent feet or less, you need to install the outlet choke. That does not apply to this furnace, so don't attempt to do that. The pressure switches, although they look identical to the ones on the larger furnaces in the product line, they're different. They have different make and break points, so don't confuse them. As you may be well aware, for example, the one facing the rear, which is the housing pressure switch, on the larger furnaces, that breaks at 0.35 inches negative. This one breaks at negative 0.10. That essentially is the point at which the furnace, if allowed to run in that condition long enough, will start to make carbon monoxide. So the research has shown us what break point is appropriate. The collector box pressure switch is the one in the front with the round tube, and that also has a lower break point than the previous ones you're used to. Here's another large difference is the gas valve has a special regulator, and you can tell by the green label you'll see on it. It's staring right at you when you take the door off the unit. And it also conveniently located has a nominal 1.5 inches water column manifold pressure setting that you should expect. Again, starting these units up, I would strongly recommend that you verify that with your manometer before you walk away from the job. The furnace also uses a lower propane manifold pressure instead of 11 inches that we're used to. This furnace requires 5.5 inches water column. And again, we're expecting you will verify that before you leave the job. The blower motor, this is a familiar device, the 1/4 horse PSC motor. It's 4 speeds. The speed taps are denoted by the colors of the wires. And as the furnace is shipped, the factory puts the black high-speed tap on the cooling speed, and the heating speed utilizes blue, which is medium-low. It uses a 25 microfarad at 370 volt capacitor. The multi-tap blower has line voltage going to it at all times. There's a black and a white wire going into the module. That's line voltage. It's, again, at all times when the furnace is powered up, there's 120 volts there. And the speed taps utilize a 24 volt signal to tell the motor what speed range it's supposed to be running at. The wire speeds are denoted by the colors, and again, as shipped, gray is cooling and blue is heating and red is continuous fan. Venting is, excuse me, is the same as the larger furnaces. You have 3 options. You can do it as a 2-pipe direct vent. You can do single pipe non-direct vent as long as you have enough ventilation air in the combustion space. Or you can do 2 pipes with 1 pipe vented outdoors and the other combustion air pipe terminating in a ventilated combustion air space, such as a ventilated crawl space or a ventilated attic. The maximum length before the deductions for elbows is as listed below, and we'll look at the venting table on an upcoming slide. And here it is. You'll notice that the only 2 sizes that are allowed are 1.5 and 2 inch. That means that if you have an existing application where someone has installed 2.5 or 3 inch pipe, you'll need to rip it out and replace it with an appropriate size. The inlet gas pressures are recommended to be the same as with the current product. We need at least 4.5 inches water column inlet pressure for natural gas. Customarily, you can expect to see a 1 inch pressure drop through a gas valve. So if you have less than 4.5 inches minimum, you'll see less than 3.5 at the manifold. Even though this one only requires a nominal 1.5 inches at the manifold, we still want to see that 4.5 inches at the inlet. Manifold pressure, again for LP at 5.5 inches, we would still like to see an inlet pressure of 12 inches. To measure the inlet pressure tap, the picture on the left is showing the underside of the gas valve as it is oriented when you open the furnace. The picture on the right shows with the arrow where that tap is located. So you should always, as part of your startup procedure, check the inlet gas pressure with the furnace running, actually with all of the gas appliances in the home running, so that you can tell if the supply system is, the piping is adequately sized, and if the regulator serving the building is in correct working order. So this is the procedure. You connect the manometer to the inlet pressure tap, turn the gas supply on, and verify that your pressure is above 4.5 inches. Remove your thermostat wire and jumper R to W. After ignition, monitor the inlet pressure to make sure it doesn't drop below the required 4.5 inches. And then only run it about a minute. After checking the inlet pressure, then you can remove the jumper, turn the gas supply valve, remove the manometer, and replace the little plug in the gas valve. Then you move to the manifold side. The pressure tap, as I'm sure you're aware if you've been working on carrier furnaces, is inconveniently located behind the outlet manifold section on the gas valve. In the picture on the left, they're using an angled hex key. I suggest getting a 3/16 straight Allen key with a 1/4 inch hex on the end, and then you can use your refrigeration service wrench. It's way faster and a lot easier. So install the manometer fitting and the manometer on the outlet. And to adjust the pressure, after you jumper R to W and the burner ignites and it stabilizes, then you can adjust the manifold pressure. The allowable range, of course, is 1.3 to 1.8 inches. They allow for differences in the heat content of the gas, but it's probably a good policy to set that to the mid-range, which is about 1.5 inches. And after you've made the adjustment with the screwdriver, briefly cover the regulator with your thumb to make sure that the regulator pressure is not affected by the atmosphere. And if everything is the way you've set it up, then you can replace the cap on the regulator stem. At that point, then you can be sure that the manifold pressure is correct. After you've adjusted the pressure, remove the jumper, turn the gas valve off, and the gas shut off to the furnace in the off position. Remove the manometer and replace the plug. Put your R wire back on the thermostat and set it to call for heat. It's probably important to make sure that both the inlet and the outlet pressure taps you've just had out of the gas valve are not leaking, and make sure that the furnace ignites and the flame burns correctly. Now this brings us to temperature rise, which is a sadly neglected item, but it's important. So remember that when you check the temperature rise, you need to have the blower door on, because it's critically important that the ductwork be involved in this calculation. So check the temperature rise range noted on the rating plate. Inside the service door on the furnace, there's a card that when you open it up, it has this label on it. And you can find the certified allowable temperature rise range published on that card. For example, you're allowed to have a 25 to 55 degree Fahrenheit temperature rise on this appliance. That generally shooting for the midpoint is best, but anywhere within that range is allowable. So in order to determine the temperature rise, you need to place thermometers in the return and the supply duct. If you only have one thermometer, well, then I would suggest taking the return air temperature while the furnace warms up. You're going to probably need to run it about 10 minutes for the heat exchanger temperature to stabilize. So if you have a low mass thermistor type thermometer, you can snake it in through the door seam or something of that nature and get a temperature in the blower section of the furnace. So you're getting a blower suction temperature. That would be your return temperature. And then when things stabilize, you can take a supply temperature reading, and we suggest you do it in the supply trunk far enough away from the plenum that you're out of line of sight from the heat exchanger, because you don't want radiant energy to affect the reading. So once you have these two temperatures, you subtract, and that subtract the return air from the supply air, and that is your temperature rise, also known as delta T. Delta is the term mathematicians use for difference, which is the product of a subtraction. To adjust the temperature rise, if you've got too much of a temperature rise, it means you're not moving enough air. So to reduce that, you would increase the blower speed. To decrease the blower speed, you would increase the temperature rise. And you change these speeds at the control board. You would simply swap out the colored wire on the heating tap and go to a slower speed if you want to slow the blower down. Now, there's a calculation you can make here which is very helpful. So this formula on the bottom of the slide, CFM equals Btu output divided by the product of delta T times 1.08. Once you have your delta T, multiply that value by 1.08. Then you go to the rating plate on the furnace and look for the BTU input and multiply that by 0.95. It's a 95% furnace. So to save you the math, this 26,000 BTU furnace has essentially a 25,000 BTU output. So if you divide 25,000 by the product of delta T times 1.08, that yields the airflow in cubic feet per minute. Sounds complicated, but if you took elementary algebra in high school, it's not. Here's an example. We have a return air temperature of 70 degrees and the supply air temperature is 110. So that gives us a delta T of 40 degrees. We have a furnace output of 25,000 BTUs. So we divide that 25,000 by 40 times 1.08, which is 43.2. If you do the math on your telephone, it's 578.7 CFM. Now, in the installation manual is a fan table. The fan table will tell you what CFM each speed will yield when matched with a certain static pressure. So what you can do is, once you've calculated CFM, see where it lands on this chart. So for example, if we have the yellow speed tap on the heating output of the control board, and you have just measured 570 CFM, the closest approximation to that is the 585 CFM, which is under the 0.6 inches static pressure column. That means that for all practical purposes, the total external static pressure that blower is encountering is about 0.6 of an inch water column. And that if you needed more or less CFM, you could change the heating tap to either the black or the orange or whatever in order to achieve the airflow that you need. However, in the example that we've chosen, the 40 degrees delta T is right in the middle of the allowable temperature range, and it falls in a fairly decent static pressure category in this fan table. So that heating speed is pretty good. Now again, this table I've put on the slide is not the complete table. The static pressure values on this table, if you check the installation manual, go up to one inch. If you're asking this furnace to run at 1 inch, it will do it. But that's the very top of the range, and it's never a good idea to run an appliance at the limits of its range all the time. So if you have your CFM calculation yields a static pressure above 0.5, 0.6, something like that, you need to go and investigate why. Are they using one of those 1 inch thick pleated high efficiency filters from the hardware store? Throw that piece of junk away and put in an appropriate filter. That doesn't have enough surface area. Pressure drop is horrendous. So look for closed dampers, blocked returns, things like that. You know what to do. The blower speed tap locations for the PSE motors, there's a cooling relay and a heating relay on the board, as you can see on the bottom left-hand corner of the board. So you would choose which color goes in the cool and what color goes in the heat by looking at the fan table. This is a photo of the board. That's the lower left-hand corner, and you've got the heating tap and the cooling tap. You'll see the spares outlined in blue there on the bottom. The white wire, which is your 120 volt common, goes on the yellow outline box, and it's labeled as such. The ECM motor uses a similar arrangement, although rather than giving you 120 volt outputs for the blower speeds, it gives you 24 volt outputs. The green wire is a common, goes on 24 volt COM down at the bottom. And then the other speeds are mounted on the heat, cool fan and the two spares. The line voltage wires, the black and white, go to the L2 neutral and the blower L1. This is a photo of the board, and you can very clearly see the 24 volt motor taps. Common is the one on the left, that would be your green wire, and the other colored wires are installed on the heat cool fan and the spare one and the spare two. The 115 volt motor lead connects to BL-1, and the motor neutral connects to neutral L2. Other tasks as you finish up the installation: making sure the filter's installed. We talked about that briefly a minute ago. Is the condensate drain connected? Remember, our best practice now for the condensate drain on the furnace is when the furnace condensate drain leaves the furnace jacket, instead of using an elbow to go straight down, we recommend you use a T and leave the top of the T open. It's called a standpipe. And it's, especially if there's air conditioning on the job, we don't want to have the air conditioner drain, when the blower is on, pressurizing the furnace condensate drain. You'll get a code 31 and it'll drive you nuts. Are the accessories installed? Have you checked the gas piping for leaks? Please leave the installation manual with the furnace. Service technicians will be very appreciative of that fact. Are the supply registers open, return grills not blocked, and are all the balancing dampers in the appropriate position? The outer doors installed and the thermostat set up and properly adjusted. Now, if we need to convert this thing to propane, this is the kit number. It's a dedicated kit for this furnace only. It's not applicable to any other kit, and no other kit will work on this furnace. It comes with a 1.25 millimeter orifices, which is similar to our other products, but here's the difference. This kit comes with a spring, although you don't need to change the spring in this gas valve. There's one in the kit. Why? Because the carrier was afraid that people would just change the spring without thinking about it, and then perhaps read that the spring change was not necessary in the installation instructions. And meanwhile, the original spring got lost or broken or stepped on or something like that. So I suppose it's a preemptive attempt on the manufacturer's part to spare you some confusion in the field. Mixer screws. On our current product, since 2011, we've been used to installing the mixer screws in the burners, and this furnace is no different. So you also have to install the low gas pressure switch, which goes on the inlet side of the gas valve. It comes with all of the brass fittings and wires and the instructions necessary for you to install that device and wire it properly. Step one would be to remove the manifold. Make sure you use a backup wrench on the gas valve. You don't want to either bend the manifold or the mounting. So disconnect the gas pipe from the valve and remove the pipe from the furnace casing. You can take the manifold and the gas valve out in one piece. You need to disconnect the gas valve wires, the hot surface igniter, and the flame sensor. Remove the 4 screws and pull the manifold assembly away. Note the location of that green and yellow striped ground wire, because that has to go back on the burner tray. We'll talk about that in a little bit. You know, flame rectification is the issue. You slide the one-piece burner assembly out. There's slides on both sides of the burner box. Remove the flame sensor from the burner assembly. Take the orifices out and toss them away. If this is to be converted back to natural gas, there's a natural gas conversion kit. So don't just toss them out. It's a good idea to look at the orifices to make sure that there's no chips or debris in them before you install them. Do not use Teflon tape or pipe dope. Finger tighten them to make sure that they're not cross-threaded, and then tighten them with a wrench or a socket. Don't reinstall the manifold yet. We've got more work to do on it. Pre-adjust the gas valve. These instructions, again, are for the green label gas valve only. It does not need to have the regulator spring replaced, but if you did it with the spring in the kit, no harm, no foul, it's the same spring. And then the regulator needs to be pre-adjusted, just as with the other units, but it's a different number of revolutions. So remove the brass cap, turn the regulator adjustment clockwise 1.5 turns. This will get the valve closer to the propane set point. Now, if the regulator spring is removed, reinstall the spring and the adjustment screw, and then turn it in 11.5 turns to get to that same pre-adjustment set point. Don't install the regulator seal cap quite yet. We need to do the LP inlet gas pressure test as we did on the previous slide. The kit contains the low pressure gas switch and all the necessary fittings and wires. This device opens at about 7.2 inches water column and closes at about 10.2 inches. And remember, this is wired in series with the pressure switches down on the inducer. So if you have an LP switch, an LP application, and you get a code 31 on that furnace, which is a pressure switch opening up, first thing you check is whether the inlet gas pressure is adequate, because that can be the cause. Don't assume you've got an issue with the venting or the inducer or the pressure switches themselves on an LP application until you verify the inlet pressure and make sure that it's not this switch which is causing the code 31. So if you assemble the switches in the, I'm sorry, not the switches, the fittings in the kit, in this arrangement, you give yourself the most convenient method for verifying the inlet pressure quick and easy. Because see where the red arrow is pointing, that pressure tap will be staring you in the face when you take the door off the furnace, and the pressure switch will be off the rear of the elbow to the left. So it's much more convenient when you do it this way. As you can see from the picture on the left, all you have to do is take the little hex plug out and put your manometer spud in that point, and you don't have to go through any gyrations to do it. The pressure switch comes with wires that will allow you to put it into series with the front pressure switch. So there are two orange wires. The straight terminals connect to the low gas pressure switch. The male spade terminal 2 connects to the orange wire of the low pressure switch harness. So you take one of the wires off the low pressure switch, and it slides onto the male number 2. The flag terminal 3 connects to the terminal on the low pressure switch. Those are the pressure switch wires going onto the low gas pressure inlet pressure switch. Here's the spot for the mixer screws. There's an indentation. It might be very faint, but that's the spot where it needs to be drilled, and it's essentially on the underside of the burner tray. Locate the dimple, and if you can't find it, figure 5 in the LP kit instructions gives you exact measurements to locate that spot. What I would suggest then is mark the spot with a Sharpie or something like that. Use a center punch or an awl to make a slight dimple, and then drill the hole then. Use the mixing screws in the bag. Do not substitute any other screws, because the length and the diameter of the screws are important. You may remember in the LP kits for the larger furnaces, there's 2 bags. There's one for the 80% furnaces and one for the 90% furnaces. And you will notice that the drill bits and the screws are different size. They're not to be confused. So this one, use the ones that come with this kit. Don't substitute anything else thinking it's good enough. It's not. It's going to be a problem. So you drill the holes, drill them as straight as possible, and you want to be perpendicular to the flow of the gas. And once it's installed, the screw head should be flush with the surface of the burner venturi. The bottom photo shows them in the installed position. Reassemble the burner. You'll notice that as you put it in, there's a notch on the front corner of the burner, and the burner slides into slots on the box. You slide it forward, and the notched area should be seated fully forward. When you install the manifold, make sure that the orifices are captured by the burner mounting rings. The burner mounting rings are made out of sheet metal, and they can be bent if you're careless. So be careful when you slide them in there that they're not egged out or bent. The problem with that is that those burner mounting rings ensure that the stream of gas coming from the orifice is going right down the exact middle of the burner venturi, which is where it has to go. The gas is then going to strike the mixer screw, which causes it to start to tumble, and it mixes better with the oxygen when it gets to the turbulator at the end. Now, the reason for this is natural gas, we don't use mixer screws because natural gas and air are fairly close in density, whereas LP is more dense than air. So that little stream of LP, if we don't cause it to mix with the mixing screw, it cuts through the air like a laser and doesn't mix very well. So that's why it's important that these burner mounting rings be undamaged and unbent, and that the mixer screws are properly installed. Hook up the green ground wire on that lower left-hand corner the way it is in the picture, and hook up your hot surface igniter and the flame sensor. Finish the LP switch wiring down at the LP gas switch. Disconnect the orange wire from the low pressure switch, number 1 in the front. Connect the flag terminal 2 to the terminal on the low pressure switch, and connect the male spade terminal 3 to the orange wire 1 removed from the LPS. This is really pretty simple. This is how it looks when it's done. So essentially, you're just taking one wire off of the pressure switch. You're routing it over through the low gas inlet pressure switch and then back to the original spot. So now you have those two switches are now in series. With the manometer connected to the inlet pressure tap, you want to turn the gas supply on. Verify the inlet gas pressure is above 12 inches. Again, remember there is a maximum limit also. You don't want to go above 13.5 inches. Essentially, anything above 1/2 psi or 13.5 inches can theoretically damage the gas valve. So, especially if this is a new installation and someone is pressure testing the gas piping, we need to make sure that the gas valves are never exposed to that test pressure if it's above 13.5 inches. Remove the thermostat wire, jumper R to W, and make sure that your inlet gas pressure doesn't drop below 12 inches. And again, don't operate it for more than about a minute. And then terminate the call for heat. Remove the manometer and replace the pressure tap plug. And that's the spot at which you would do it. Go to the manifold pressure as we did in the previous slides. Install the tap on the outlet of the gas valve, jumper R to W, and adjust your manifold pressure after the burner stabilizes. And again, we want to go to 5.5 inches water column. And once you're done with the adjustment, plug the regulator with your thumb to make sure that it doesn't change. And then if you're good to go, you can replace the seal cap and turn the unit off and remove your measuring equipment. Make sure that you put the plug back in and we don't have any leaks. You remove the jumper, remove the manometer, install the pipe plug in, put the thermostat wire back on, turn it on, make sure we don't have any leaks. Make sure that it ignites promptly and smoothly and stabilizes. From the time the gas valve is powered up, there's a 5-second window for the flame sensor on the other side of the burner to recognize the flame rectification. So if we have delayed ignition due to a misalignment or a pressure issue, that will cause a flame failure code. Adjust the temperature rise as we did with the natural gas. The temperature rise range will be the same. If you need to reduce your temperature rise, you can increase blower speed. If you have to increase temperature rise, you can decrease blower speed. Here's an important point. I get a lot of calls by guys working on LP equipment, and they don't know what orifice is supposed to be in it, and they don't know what manifold pressure they're supposed to be looking for, because for one reason or another, this conversion label is nowhere to be found on the furnace. So I know it sounds stupid and legalistic for me to be harping about this, but you need to put these labels on the appliance. Number one, it's code. Number two, the next guy down the steps into the basement who has to work on this stuff needs this information if he's going to do his job. Again, you're supposed to put this conversion label on, fill it out, use a Sharpie or something, and make sure that it's there. And it's helpful to put this on the gas valve. Again, this is a safety thing so that if for some reason somebody who's unfamiliar with this application stumbles into the basement to work on this thing, and it's really helpful for them to know, even if there's nobody there to tell them, what fuel is being applied to this appliance. It's important. So run the furnace through 2 heating cycles. Verify that your temperature rise is okay. Make sure before you leave that the gas and electric are still on. Perform any final gas leak checks you need. And make sure that any accessories, humidifiers, etc., are installed in the furnaces. The filter is properly installed. Make sure the doors are on and secure, and the thermostat's properly set. That's the end of the show. If you have any questions, you can type them in now to the chat room, and we will respond. Thank you.